Before we jump into our new lesson, let us have first a recap of what has been discussed by the previous reporters. According to their discussion, seismograph is an instrument that measures ground displacement. Seismogram are records obtained from the seismograph. Seismic intensity scale is a series of certain key responses such as people awakening, movement of furnitures, total destruction, and many more. And lastly, magnitude versus intensity. Magnitude is a measurement of the size of an earthquake, while intensity measures the strength of an earthquake. These two are different aspects but relate with each other in terms of damage impact and damage caused by the earthquake. Vibration is defined as oscillation, reciprocation, or other periodic motion of a rigid or elastic body or medium force from a position or stage of equilibrium. In other words, ground shaking is a term used to describe the vibration of the ground during an earthquake. Ground shaking is caused by body waves and surface waves. As a generalization, the severity of ground shaking increases as magnitude increases and decreases as distance from the causative fault increases. There are different types of vibration. First is free vibration. Occurs when a mechanical system is set in motion with an initial input and allowed to vibrate freely. The mechanical system vibrates at one or more of its natural frequencies and dumps down to motionlessness. Second is forced vibration. It is when a time-varying disturbance is applied to a mechanical system. The disturbance can be a periodic and steady-state input, a transit input, or a random input. And lastly, damped vibration is when an energy of a vibrating system is gradually dissipated by friction and other resistances. The vibrations gradually reduces or change in frequency or intensity or cease and the system rests in its original.
Let's proceed to the sources of vibration. Vibration, which is commonly referred to as noise, can be segregated into three main categories, and these are the seismic ground vibrations, acoustic vibration, and the forces applied directly to the load on the working surface. Seismic vibrations. Earthquake and underground explosions can release a lot of energy, and that energy ripples away from its source in a variety of ways. Some waves travel forward and back through the material, and some travels like ocean waves kung saan napapagalaw nila yung materials na nasasalubong nila by moving up and down. Seismic waves are vibration or disturbances that propagates from source, such as explosions or shock waves, through the earth until they encounter a reflecting surface and are reflected into a detector. It includes all sources that make the floor under the experimental setup vibrate. The common seismic vibration sources are foot traffic, vehicular traffic, wind blowing the building, and building ventilation fans. Acoustic vibration. It is the movement of particles in an elastic medium about an equilibrium position and is also known as acoustic oscillation and sound definition. Karamihan sa sources na generate ng seismic vibrations are also generated by acoustic vibration, kaya parang same lang sila. The difference is that the acoustic vibration are a measure of the effects of air pressure variations on the experiment. The last source of vibrations are the forces applied directly to the load on the working surface, which is the final contributor to vibration. These are vibration sources that are directly coupled mechanically to the experimental setup but not transmitted through the table supports. Examples include vibrations resulting from a moving positioning stage with a sample on top of it, or the vibration transmitted to the working surface via the vacuum system tubing.
Attenuation, the reduction of the amplitude of a signal, electric current, or other oscillation. So ito yung nalilessen or nawiweaken yung force, amplitude, and magnitude. So ang best illustration nitong attenuation ay kunyari, nagbato ka ng isang bato sa tubig. Once na tumama yung bato sa tubig, nagpo-form ito ng waves sa surface, palayo sa part or sa lugar na kung saan lumubog yung bato. Mapapansin natin na noong una ay malaki yung waves, pero habang lumalayo ito, lumiliit na ito. So itong pagliit ng waves na ito yung tinutukoy na attenuation. Seismic waves also become attenuated as they move away from the earthquake source.
Seismic attenuation is an intrinsic property of rocks causing dissipation of energy as seismic waves propagate through the subsurface. It results in the decay of amplitude of the seismic waves. This means the energy of seismic wave is conserved if it travels through a perfectly elastic medium. Propagating seismic wave lose energy due to absorption, geometrical spreading, and scattering.
Geometrical spreading. As the sound moves away from the source, the area that the sound energy covers become larger and thus the sound intensity decreases. This is independent of frequency and plays a major role in sound propagation situations. Seismic wave amplitudes vary as they travel across the Earth. As the wave front moves out from the source, the initial energy released in the seismic wave is spread over an increasing area and therefore the intensity of the wave decreases with distance. However, the geometric spreading alone cannot describe the attenuation of seismic wave energy. The decrease of kinetic energy of seismic wave is also due to the energy absorption caused the imperfections in the Earth. This is the case when the elastic energy is completely transmitted to the mantle.
Anelastic attenuation. There is another factor that affects seismic amplitudes. This is the energy loss due to anelastic processes or internal friction during wave propagation. This is called anelastic attenuation. Attenuation occurs mostly during shear wave motion associated with lateral movements of lattice and grain boundaries. When traveling through subsurface, anelastic waves' mechanical energy is converted to heat energy due to friction and changes in viscosity. It occurs at interface boundaries such as water, gas, formation, and grain boundaries. This transformation results in decrease in amplitude and pulse broadening. As the wave travels away from the source, the pulse broadens with increasing distances. As the wave spreads, attenuation removes the high-frequency component of the pulse.
Scattering. Attenuation is frequency dependent and is strongly affected by scattering. Scattering is an important factor caused by heterogeneity of the Earth's crust and mantle and availability of hydrocarbon reservoirs. So ano ba kapag sinabing heterogeneity? Ito yung quality of consisting of the similar or diverse element. So dahil nga diverse ang elements ng Earth's crust and Earth's mantle, once na nagkaroon ng seismic wave, madaling mag-i-scatter yung waves na nagre-result sa attenuation of seismic waves. So, madaling humihina yung mga waves.
Vibration dumping. Vibration absorbing or vibration dumping tools and measures make it possible to noticeably reduce vibration levels of shipboard structures, attenuate vibration activity of propulsion plant machinery, and thus diminish vibratory energy transmitted to ship hull, which is a major source of excessive underwater radiated noise levels. Vibration dumping tools enable reductions of resonance structural vibrations in lower and medium acoustic frequency bands, as well as the attenuation of vibration energy over propagation path at a higher acoustic frequencies. The efficiency of vibration damping means depend on the properties of vibration absorbing materials as well as on the service conditions of the structure to be damped. Manufacturing requirements, sanitary chemical regulations, and operating specifications. In this connection, it is required, on the other hand, to select appropriate anti-vibration means for a specific structure, and on the other hand, to find a rational arrangement to accommodate these tools.
Damping and its importance. Damping is essential for vibration control in construction. With a high loss factor, cork is an excellent damping tool, boosting security and comfort in buildings and infrastructures. Each material's damping capacity is referred to as its loss factor, and this represents the ratio between dissipated energy and the energy remaining in the system during each cycle. This means that damping is the dissipation of vibratory energy in solid mediums. Similar to the absorption of sound in air, damping occurs whenever there is any type of friction that diminishes movement and disperses the energy. It is essential in construction because damping limits the vibration and ensures security and comfort in buildings and infrastructures.
Types of vibration. So alam naman natin na itong vibration ay isa sa factors na kailangan i-consider kapag nagbibuild ng isang structure. So yung structure na dinidesign natin, it should have capacity to dissipate that energy. So dito na pumapasok yung damping types. And there are two types of damping. The viscous and the hysteretic damping. Viscous damping depends on frequency, while hysteretic damping assumes nonlinear relations between stress deformation. Some materials, such as a structural steel, are almost ideally elastic up to the elasticity limit. And with these materials, that type of dissipation can occur during stress much lower than the stress of the elasticity limit. It can be explained by concentration of stress and residual stresses. So to conclude, damping lowers amplitude during vibration of structure. So itong damping devices or itong damping, nalolower nito yung amplitude na natatanggap ng structures whenever there's a vibration. And with viscous damping, the damping force is proportional to the speed. The damping force of column damping is constant. While in solid damping or hysteretic damping, it is caused by internal friction when a solid is deformed. Each size is related to the amplitude of stress. So there are other types of damping, but they are often replaced by viscous damping in order to linearize equation of motion which would facilitate its solving. However, it is not necessarily adequate way. Viscous damping. For viscous damping, we have force-velocity relation in an equation of F equals T times V raised to M, where F is force, C is damping constant, and B velocity. Proportion between damping and critical damping for viscous dampers is 0.61. Solid damping, structural damping, or hysteretic damping are terms that determine internal damping. Energy dissipated in a cycle is dependent on frequency for this type of damping. It has an equation of F equals K times X, where F is force, K is constant of hysteric damping, and X is displacement. Hysteric damping constant is a measure of hysteric loop and a feature of material or structure. Energy dissipated for each cycle is not proportional to the square amplitude of motion. Significant damping type is column friction damping. It is also called constant damping kasi the damping forces are independent of displacement.
What are the key considerations when choosing a vibration damper? First is a good damping coefficient. A damping coefficient is a material property that indicates whether a material will bounce back or return energy to a system. A basketball has a low damping coefficient. If the bounce is caused by an unwanted vibration or shock, a high damping coefficient will attenuate the response, meaning it will swallow the energy and reduce the reaction of the system. Second is the wide temperature range stability. The temperature range stability for materials must be known for use in extreme application environments. The effects of exceeded temperature ratings vary and the importance depend on the performance requirements of the application. Third is a long fatigue life. Fatigue is failure under a repeated or varying load, never reaching a high enough level to cause failure in a single application. Subroutine combines shock absorption, good memory, vibration isolation, and vibration damping characteristics into one solution. In addition, subroutine is a very effective acoustic damper and absorber. While many materials exhibit one of these characteristics, subroutine combines all of them in a stable material with a long fatigue life.
We can conclude that dampers are very necessary for a variety of reasons. Their rigidity has an effect on a period of time. Because of the piers, it takes a long time and reduces the maximum time displacement. The amount of energy entering a building is more uniformly distributed. As a result, they recently become more frequently used. We can also conclude that the structure's damping impact is very significant. The dampers fade away, such that the structure absorbs less energy. This means that the energy is saved as a result of their installation.
May pa-short quiz po
Seismograph
kami.
is
Sana po
an instrument that measures ground
maki-cooperate po lahat. Isi-send po namin yung link sa chat box po. Wait lang po. Sa GC na lang po pala. Sino pa po ang hindi pa po nakaka-join?
Everyone, please participate. Thank you.
Kompleto na po. Start na po namin. So, congratulations po kay Sha. Paki-PM na lang po kung sino po siya. Mag-PM na lang po sa akin. Thank you po.
Okay, thank you. So, do sa reporter, wala kayo nakitang any video na related do sa topic nyo? Para at least pampahaba din about attenuation.
Wala po kami masyadong ma-search po, sir.
Okay. Anyway, i-ano ko na lang, pass ko do sa kabila, yung link do sa video. Kasi may flash ka sila kanina. Anyway, it's okay. Sige, thank you. Bigyan naman natin ng virtual applause yung first set of reporter. And the next topic natin, yung time history development. So you may now start presenting your report.